Hello, my name is Wil van der Aalst and it is a great pleasure to give this short introductory talk for the 4th Process Mining Conference in Japan. I'm very happy that process mining is also getting traction in Japan. It's a pity that I cannot be there, but it's good to see that the Association of Process Mining in Japan is making a lot of efforts to, let's say, show the value of process mining and also train people in this area. So we'll basically talk about the developments in the field of process mining, let's say in the last 1 or 2 years, and try to stress the point that we need to move from 2D to 3D process analytics. What I mean by that, I will explain in a couple of minutes. So here's some background information. I think most of you know who I am. I'm both a professor at RWTH Aachen University. I'm also the chief scientist of Celonis. And I've been working on process mining, let's say, basically for the last 25 years. But let's not talk about me. Let's talk about process mining. And I would like to start by showing, let's say, a pit stop of Max Verstappen. So I'm Dutch, so we are very proud that now, let's say, a Dutch Formula One driver is being so successful. And you probably have seen that Red Bull is often taking the record in making the fastest pit stop. As you can see that in slow motion, in less than 2 seconds, 4 tires are being replaced. And this requires that things are happening concurrent and there are multiple people and multiple objects involved at the same time. So there are multiple people taking off one of the tires, putting on a new one, etc., etc. So this is illustrating that in many processes in real life, they are not completely sequential, they are highly concurrent and multiple objects are involved. And I will come back to that topic, let's say, later. But let's first start with the standard overview. So I'm sure that many of you have seen already this diagram. It is basically showing the life cycle of a process mining project. So we start from event data, then we discover processes, then we combine the event data with the discovered process models. Based on that, we can do performance and conformance analysis, showing where are bottlenecks, where are deviations. If one has enough data, one can even, let's say, use these models to apply machine learning techniques. So, for example, to predict that tomorrow there will be a bottleneck in this part of, for example, a production process. Or if you are looking at compliance questions, that you see this is now a case that has a high likelihood of deviating or leading to some unsuccessful result. So I don't think that I need to explain this to this audience. What I always like to stress is that process mining is super generic. It can be applied in any application domain, in hospitals, in production, in sales processes, to mine educational processes. The possibilities are endless. And we are probably only have reached, let's say, 1% of its potential. So the process mining market is expected to grow, let's say, by 50% each year. So we can clearly see an exponential growth over the last couple of years. This shows the history, starting in the late 90s when I had my first projects, let's say, looking at very foundational process mining questions, until now, where we are in the luxurious situation that many organizations, specifically in the north of Europe, are applying process mining already at a large scale. And at the same time, there are many, let's say, process mining vendors on the market. So this timeline shows the, let's say, spectacular development of the field. As I mentioned at the beginning, I'm working as a professor at the university in Aachen, but at the same time, I'm the chief scientist of Celonis. And Celonis is clearly the most successful company in this area, but it is definitely not the only one. Here you see some logos of other, let's say, process mining vendors that are out there. and the sheer number of vendors is indicating, let's say, that people are expecting a lot from this technology. If you look at, for example, takeovers, then you see that there is an interesting development in the field. You can see that many of the, let's say, smaller vendors are being taken over by larger vendors. This started basically when UiPath, an RPA vendor, bought Process Gold. Then this was followed by SAP buying Signavio for over, let's say, 1 billion euros. Then IBM purchased MyInvenio. Appian purchased Lana Labs. And this was like a bit of an atypical takeover that Celonis bought PathNow to have a better representation on the Microsoft platforms. Very recently, Microsoft bought Minute. So what this shows is two developments. A, that the larger software vendors like SAP, IBM, Microsoft, etc., they clearly see the value of process mining. I think that's one development we can see. Another development that we can see is that process mining is increasingly connected to automation. So if using process mining, you see a big problem, then you don't want to just diagnose the problem, you want to take automatically actions, and let's say the movements in the markets are clearly showing this development. So let's go a bit to the topic that I had in my subtitle, going from 2D to 3D. So this is 2D, 2 dimensions, normal event data, where every event can have many attributes, but the minimal information that we should have is that an event refers to a case, an activity, and a timestamp. I'm quite sure that all of you have seen, let's say, such introductions before. However, if you look at real life information systems, you need to make quite a bit of effort to extract data from these systems and squeeze it into this format where for every event we have a case identifier, an activity name, and a timestamp. So the difficulties are finding the data, cleaning the data, data quality problems, but above all, using process mining in the classical sense, you're kind of forced to pick a single case identifier. And this is very difficult. If you're dealing with a system like SAP, you're dealing with, let's say, hundreds and sometimes thousands of tables, and you need to reduce it to this single, let's say, 2-dimensional view. Well, the real systems and the real processes that you're looking at are very much 3-dimensional. So this often feels like if you go from all of these tables to such a simple event logging format, it feels like pushing an elephant through a keyhole. And after doing that, you just look at the data from a single viewpoint. If you want to modify your viewpoint, you have to again push another elephant through the keyhole. So the idea of object-centric process mining is to address exactly this problem and going from 2 dimensions to 3 dimensions. A standard example that I often use to introduce that is if we look at ordering items from an online shop, for example Amazon. Every order can consist of multiple items. Items are being shipped in packages, and one package can contain multiple items, possibly of different orders. We try to deliver these packages to people at their home. They may be at home or not. So the same package can be on multiple routes, and on one route there can of course be multiple packages. So this is visualizing this in an abstract way. So here we have 3 orders, we have 7 items, we have 4 packages, we have 3 routes, just to make it very simple. And if you look at the connections between orders and items, you can see that in one order there can be multiple items, but these items can be distributed over multiple packages, etc., etc. So if you would look at the indirect relationship between orders and packages, we have a many-to-many relationships. Items from one order can be scattered over multiple packages, and inside one package there can be items of multiple orders. And these packages can be on multiple routes, etc., etc. So if you look at this, complexity, and you now want to squeeze such an elephant through the keyhole, you need to decide what is your case notion. Is it orders, items, packages, or out? And this is very difficult. So in our research, and what we see a trend increasingly also in systems like Celonis, is that we no longer say that an event requires a single case notion, but if we look at an event, it has an activity, it has a timestamp, just as before. It can have any number of attributes, that also didn't change, but the new thing is that an event can refer to any number of objects. Very different than before, where every event could only refer to a single case. So what you see here in blue is what we already had. So events refer to activities, have a timestamp, and may have attributes. But the new thing is that instead of linking an event to a single case, an event can be linked to any number of objects of many different types. And here you can see some examples. So if you look at this table, then for example, if I look at a particular event, that may be a place order event that refers to one order and multiple items. If we look at the pick item event, it refers to just one order and a single item. If we look at the failed delivery, it is referring to a package, multiple items, and these items may originate from multiple orders. So this is much more realistic, and in this simple example, we just have 5 object types. If you look at real-life settings, the number of object types may be much larger. So if this is our reality, and we understand that this is what is really happening in information systems and in real processes, the question is, can we now, based on this, create a conventional event log to do that? And of course, we can go back to our original approach where we said, okay, we just have a single case notion, and based on this case notion, we create a new log where we replicate each event for every case that we have. So if an event is referring to multiple objects of the type that we selected as our case notion, we will have that one event will actually correspond to multiple events. So if in this example we just look at a row that is highlighted here, it's a place order event that refers to a single order. So if we take orders as a case notion, this event is corresponding to, let's say, a classical event. If we look at items and we take items at the case notion, this original thing that happened, this original event, is referring to 2 items. So if we pick items as our case notion, we need to replicate this event. So we have 2 place order events, although in reality it was only 1. If we pick packages as a case notion, then simply this event place order is lost because it doesn't refer to an item. So to make this more visual, but it's the same idea, at the left we see the original events, where one event can refer to any number of objects. On the right, what we see is let's say, a classical event log where we have picked a particular case notion. In this example, we picked case as orders as our case notion, and that means that, for example, send package, this event that was referring to 2 orders, is now replicated. So in green highlighted here, we see that there are 2 send package events corresponding to the original send package event, which was actually precisely 1 event, but it contained, let's say, items of multiple orders. If we pick items as a case identifier, we can see that we have even more replication. So we can see that the original place order event is split into 2 events, and the original send package event is split into 3 events, one event for every item in the package. If we take package as a case notion, we can see that many of the original events are actually not captured. We only have the send package event from this small, let's say, subset. So if we do this, it is perfectly fine, but we have to realize that we are projecting this 3D reality onto a 2D reality. So we may have the deficiency problem, that means that certain things have disappeared. We can have the convergence, let's say, problem, that in our original process, in our original system, there was one event. A person pushed the button, place order, and that led to a burst of, let's say, changes to different tables, leading to many low-level events, although it was one event in the real world. And this is the result of this flattening. The converse of convergence is divergence, and that leads to the problem that we are picking a case notion at a level that is relatively coarse. Because of that, we see, if we look, for example, at the directly follows graph, we see events following each other that are actually not causally related. So if we are doing order picking for different items in the same order, and we pick order as our case notion, we will see that we pick one item followed by picking another item, although they are causally unrelated. They are related to placing the original order. So there are many different challenges, and my recommendation at this point in time would be to be aware of this problem and to store your data in an object-centric way. Do not flatten your data. Like you still need to do that if you want to apply a conventional process mining tool, but postpone it. If you store your data, store it as it really happened in an object-centric way. Only if you start doing analysis, then you convert it to a flattened log where you have these problems like convergence, divergence, and all the things that I mentioned. What is important is that the events that you store correspond to reality and not some kind of distorted reality just because it was stored in a fragmented way. Seeing this, you will also realize that often we get spaghetti diagrams because we are flattening our data and are unable to handle concurrency. And so if we have an order that consists of multiple items, and for each of these items we execute certain steps, if we just use the classical process mining approach, we will see lots of loops in our diagrams that are actually not loops at all. They are just things executed for every item, let's say separately, or things that are, let's say, simply concurrent, where the ordering does not matter. So you can already apply these insights today if you're, let's say, applying process mining. So I hope that you now understand this, let's say, image better. Just imagine as a process as things where multiple objects are flowing through our processes. This is highly concurrent. These objects are partly independent, but as you can see in this example, in the end it all has to fit together and the car is driving away successfully. So I realized that this message is a bit complicated. So considering multiple object types at the same time makes life more complicated. But it is extremely important that if we do process mining, we try to find the true fabric of operational processes. We need to capture reality as it is, not some distorted, let's say, 2D simplification of reality. As always, if you're interested in process mining and you would like to learn more, you can let's say, look at the books that I wrote. You can look at the, let's say, different courses that I created. At the end of last year, we released a course called Process Mining from Theory to Execution. And this is a course which is linking, let's say, concrete applications using the Celonis system to, let's say, the theory that is behind it. If you take these courses, also lots of, let's say, data is available that you can play with it. And in these courses we also talk about this problem of dealing with a 3D reality while often having 2D tools. Enjoy very much the conference. Thank you very much.